Hello everyone, hope you're all doing great. Now we are going to discuss about the development of the fetus. So, in embryology, 0 to 2 weeks after fertilization is known as pre-embryonic period. 2 to 8 weeks after fertilization is known as embryonic period. After 8 weeks till birth is known as fetal period. In this fetal period, if there is any teratogen exposure in the form of drugs, viruses or radiation, there can be chance of congenital anomalies. So, how will be the growth of the fetus determined? It is basically determined in the first half of the pregnancy by genetic factors and in the second half of the pregnancy by the environmental factors. So, for the growth of the embryo, there are some factors like hormones like insulin like growth factors, and some other growth factors also play an important role. Next one is race. For example, the European babies are bigger when compared to Indian babies. Then, about the general stature of the mother, if there is a taller and heavier mother, the babies are also big. Then, about the sex of the baby, male fetuses are generally big when compared to the female counterparts. Then is about the socio-economic status. Socio-economic status 1 and 2 will have more bigger babies. Now coming to the changes that happen in the fetus during fetal development. Okay. So normally the swallowing movement will be seen during 10 to 12 weeks. Breathing movements start at 11 weeks, and here in the lungs, the surfactant production starts around 20 weeks, and the surfactant is seen in the amniotic fluid around 28 weeks. Limb movements start around 7 weeks of gestational age. Urine production starts around 8 to 11 weeks of gestational age, and meconium production is around 16 weeks of gestational age. Fetal heart starts beating around 5 weeks of gestational age, which is 21 days after fertilization. Okay. Regarding the gonads, male gonads develop earlier than the female gonads. Male gonads are seen around 7 weeks of gestational age and the female gonads are seen 1 week later, maybe 8 weeks of gestational age. Internal genitalia and external genitalia. Then the internal genitalia seen around 10 weeks and external genitalia seen to develop between 11 to 12 weeks of gestational age. We'll see some of the important systems in the fetal development. First system is the cardiovascular system. We'll see some of the points on the development of heart. So, fetal heart basically develops in the cardiogenic mesoderm. This region, at first, it is seen cranial to the, but after the formation of head and tail folds, this becomes caudal to the precaudal plate. Basically, heart develops from two tubes. Okay, we have two tubes like this, and these two tubes will start fusing from the upper end to the lower end to form a single tube, but the fusion in the lower end is not complete. And one more point you have to know is the upper end is the arterial end and the lower end is the venous end. Okay. At one point what happens is folding happens in these tubes, that is cardiac looping, and various dilatations are seen to form in the heart tube. For example, so this is the picture. First we'll have a endocardial tubes, two tubes are present. They will fuse together to form a single heart tube. So the various folds that are formed in the heart tube include number 1, bulbous cordus, number 2 is the primitive ventricle, number 3 is the primitive atrium and the sinus venosus. These together is also known as sinoatrial chamber. We also have the truncus arteriosus. Okay. So, truncus arteriosus basically forms the lowermost portions of aorta and inferior vena cava. From the bulbous cordus, we'll have the smooth part of the ventricles. From the primitive ventricle arises the trabeculated part of the ventricles. Then in the sinoatrial chamber, we have the primitive atrium which will be giving rise to the trabeculated part of the atrium and sinus venosus will give rise to two parts from its two horns. There are two horns, namely the left horn of the sinus venosus and the right horn of the sinus venosus. Left horn gives rise to the coronary sinus and the right horn gives rise to the smooth part of the atria. Fetal heart circulation is established on day 21. Fetal heart starts beating from day 22 and circulation to the rest of the embryo starts between day 27 to 29. One more point is, how does the nutrition is established throughout the intrauterine life? First one is absorption. It happens through the absorption of nutrients from the uterine and the tubal fluid. Second mode of nutrient transfer to the fetus is by the histotrophic transfer. This is basically the transfer of nutrients from the decidua by diffusion. And the third type of nutrition is the hematotrophic transfer, and this happens after fetal circulation begins. I hope you have understood. Now, we'll see about fetal circulation. Before going into the actual concept, I want you to tell some important points on fetal circulation. So, the first point is, remember, the lungs in the fetus are not functional. Second point, the pulmonary vascular resistance is high because the lungs are not functional. Automatically, the systemic vascular resistance is less. And the fourth point is, you have three important shunts that are present in the fetal circulation. Number one is the ductus venosus. Which helps in shunting the blood between the umbilical vein and inferior vena cava. Number two is the ductus arteriosus, which is a connection between pulmonary trunk and aorta. Number three is the foramen ovale, which is a connection between the left and right atrium. Another concept is that usually in adults, arteries carry oxygenated blood and the veins carry deoxygenated blood. But in fetal circulation, when we consider the umbilical vein and umbilical artery, umbilical vein carries oxygenated blood, whereas umbilical artery carries deoxygenated blood. We'll see the circulation. We'll have the placenta. So, placenta is the site of oxygen supply in case of fetal circulation. All of you know we have two umbilical arteries in the umbilical cord and one umbilical vein. So initially we'll have two umbilical veins, the right and the left umbilical vein, but the right umbilical vein goes for degeneration and only the left umbilical vein is left. Okay, so this is the left umbilical vein and these are the umbilical arteries. Basically, umbilical arteries are the branches of anterior division of internal iliac artery. Okay. Now what happens is, from the umbilical vein, the blood will pass through the portal system. Okay. And will have the liver there. Okay. So in fetal circulation, it is the brain and upper limbs that need most of the oxygenated blood. So what is happening here is, there is a ductus venosus which helps in shunting of the blood from the left umbilical vein to the inferior vena cava. So this is the ductus venosus and let's consider this as the inferior vena cava. So what happens is, most of the oxygenated blood that is coming from the placenta through the left umbilical vein is now shunted into the inferior vena cava. In inferior vena cava, we'll have both oxygenated and deoxygenated blood. Okay. So this presence of both oxygenated and deoxygenated blood in inferior vena cava will be streamed into two compartments. So ideally the medial compartment and the lateral compartment. Okay. So the medial compartment consists of oxygenated blood, whereas the lateral compartment consists of deoxygenated blood. And medial compartment oxygenated blood comes from the placenta, whereas the lateral compartment oxygenated blood comes from the liver, lower limbs, pelvis and even the kidneys. So what happens is, so the blood is passing through this inferior vena cava. As the blood is coming and reaching the heart, it will reach the right atrium. This is right atrium, right ventricle, left atrium and left ventricle. Okay. So there is an opening, that is a connection between the right atrium and the left atrium, that is the foramen ovale. Okay. Now what happens is, this blood from the inferior vena cava is now reaching the right atrium. In the right atrium, what happens is, most of the oxygenated blood, okay, most of the oxygenated blood goes via this foramen ovale and reaches the left atrium, and some of the deoxygenated blood, okay, I will mark it in black color, this is deoxygenated blood, so that is reaching through the right ventricle, okay. Now what happens is, from the left atrium, the blood will pass to the left ventricle, and in the left ventricle, from the left, the blood from the right atrium passes to the left atrium and it will pass to the left ventricle, and from the left ventricle we will have the aorta that will be taking the oxygenated blood and will be supplying the brain and the upper limbs. Now what happens to this deoxygenated blood that has been received in the right ventricle? Ideally what should happen to the right ventricle blood is, it should pass through the pulmonary trunk and it should pass through the lungs, okay. It should go to the lungs to supply the pulmonary circulation. But here we know that this lungs are not functional and the pulmonary vascular system is also high. So what happens is, there is basically one connection between the pulmonary trunk and the aorta, that is the ductus arteriosus. So via this channel, what happens is, blood will pass through this channel and reaches the aorta again, and some of the blood will be reaching the placenta for purification and some of the blood will be reaching the lower limbs, okay. Also, some of the deoxygenated blood that is entering the pulmonary trunk will be sent to the lungs, okay. There is no action in the lungs, but for the growth of the lungs, some amount of blood supply is needed, okay. So that is provided through the circulation. I hope this would have made sense, and we'll see it once again through the picture that will give you a clear idea. So this is a fetal circulation, okay. So first what we'll have the placenta and the umbilical arteries. Umbilical arteries here are receiving the deoxygenated blood. It is the umbilical vein that is going to supply the oxygenated blood, and the umbilical vein blood is directly going into the portal vein. So there is no need of supplying of oxygenated blood to the portal vein. So there is a shunt called ductus venosus. This is the ductus venosus, which is a connection between the inferior vena cava and the umbilical vein. So most of the purified blood that is received from the placenta will be shunted into the inferior vena cava. Inferior vena cava contains both oxygenated and deoxygenated blood. Oxygenated blood lies in the middle part of the inferior vena cava that is received from the placenta, and deoxygenated blood that is received from the lower limb, pelvis and liver lies in the lateral side of inferior vena cava. This arrangement of oxygenated and deoxygenated blood inside the inferior vena cava is known as streaming. Now, as the blood from the inferior vena cava reaches the right atrium, most of the oxygenated blood is going to the left atrium via the foramen ovale. Now, from the foramen ovale, the blood that has reached the left atrium will be reaching the left ventricle, and through the aorta that will be supplied to the brain and the upper limbs. Also, if you see the right atrium, it receives blood supply from the superior vena cava, which is the deoxygenated blood, and some of the deoxygenated and oxygenated mixed blood from the inferior vena cava also. So this blood will be reaching the right ventricle. Ideally, what happens in adult circulation is, the blood from the right ventricle will be shunted into the pulmonary trunk and it will be supplied to the lungs for purification. But here, the pulmonary system is not functional. It is a highly resistant system here. So what happens is, there is another duct called as ductus arteriosus, which help in shunting of the blood from the right ventricle, blood that has entered the pulmonary trunk into the aorta. So this is less oxygenated blood. Okay. So what it will be doing is, via this ductus arteriosus, it will be coming through the descending aorta, and some of the blood will be reaching the lower limbs for the growth and nutrition of the lower limbs, and some of the blood will be reaching via the umbilical arteries for purification. Okay, so this is fetal circulation. I hope I would have made some sense to you. Okay, now what are the changes in the fetal circulation after birth? Number 1, initially in the lungs there are only fluid, right? So it was a increased resistance was seen in the lungs, and it was a highly resistant system. But after the first try, what happens is this fluid is now replaced by air, and hence the pulmonary vascular system becomes a less resistant system. Okay? And as the lungs become functional, cardiac output increases by 5 to 10%. So, the left atrium now receives more blood, and hence the systemic vascular system resistance is more than the pulmonary vascular system. Now, due to this resistance, what happens is the foramen ovale closes. Okay. Also, the ductus venosus, ductus arteriosus also close, and they are left behind as ligamentum venosum and ligamentum arteriosum. Also, the left umbilical vein will be converted to become the ligamentum teres of liver, and the umbilical arteries will now become the medial umbilical ligament. Understood? So, this part is very important. Number 1, the foramen ovale closes. Number 2, what are the changes that happen with the ductus venosus, arteriosus, left umbilical vein and umbilical arteries. So, ductus venosus becomes the ligamentum venosum, ductum arteriosum becomes the ligamentum arteriosum, umbilical arteries become the medial umbilical ligament, and the left umbilical vein becomes the ligamentum teres of the liver. Okay. Now, we will see some points on fetal erythropoiesis. Fetal erythropoiesis generally takes place in the order yolk sac, liver, spleen and bone marrow. You can remember this as yes, I love sea banks. Okay. So, it is the yolk sac, it is the liver, it is the spleen followed by the bone marrow. So, the erythropoiesis in the yolk sac happens between 3 to 8 weeks. In the liver, it happens between 6 weeks till birth. In the spleen, this happens between 10 to 28 weeks, and in bone marrow, it starts between 18 weeks and it continues till the adult life. You have to know the difference between fetal hemoglobin and adult hemoglobin. Fetal hemoglobin consists of two chains, namely alpha 2, gamma 2. whereas adult hemoglobin consists of two chains, namely alpha 2 and beta 2. Fetal hemoglobin is the maximum type of hemoglobin that is seen in intrauterine life. 80% of the hemoglobin or fetal hemoglobin type during birth also. Adult hemoglobin production will start around 24 weeks of gestational age, and by 6 to 12 months after birth, this will become the maximum amount, and only less than 1% of fetal hemoglobin will be seen after that. Okay. Now we have to know about the fetal hemoglobin. Fetal hemoglobin is having higher affinity to oxygen, and it has less affinity to 2,3-bisphosphoglycerate. Also, it is highly resistant to alkali and acid denaturation. So, this concept is used in two tests, namely Singer's alkali denaturation test and Clay-Hoyer Bedke test. So, what is basically happening in the Singer's denaturation test is, we are going to test whether the bleeding is via the vasa previa or the placenta previa. Okay, we are going to check the quality of the blood. So, it is a qualitative test. Okay, here we will be using the reagent 1% potassium hydroxide or sodium hydroxide. And in Clay-Bedke test, we are going to check the quantity of the blood. Okay, ideally this test is done in RH negative pregnancy if a bleeding is suspected. Okay, and the reagent used here is citrate acid phosphate. Okay, now we are going to see about the respiratory system in fetus. Respiratory system development starts from week 4, and the lung development happens in 4 stages, namely embryonic stage, pseudoglandular stage, canalicular stage, saccular stage, and the alveolar stage. There are two types of pneumocytes that is present in the alveolus, and also you have alveolar macrophages. Say this is type 1 and this is type 2. So, these are nothing but the type 1 pneumocyte and type 2 pneumocyte. Among this, type 2 pneumocyte is very important because this acts as stem cells for the other types of cells, as well as they produce surfactant also. Coming to surfactant, what is the importance of surfactant? Surfactant reduces alveolar tension, prevents alveolar collapse, increases compliance of the lungs. Basically, surfactant production starts around 20 weeks of gestational age, and it is seen in the amniotic fluid around 28 weeks of gestational age. In the amniotic fluid they can be seen. What are the tests for lung maturity using this surfactant? Most commonly done test for lung maturity is lecithin sphingomyelin ratio, where we will be checking the ratio of lecithin and sphingomyelin. If it is more than 2, then lung maturity is said to be attained. Second test is phosphatidyl glycerol test. This is not commonly done, but this is the most sensitive and specific test. Another test is the Nile blue sulfate test. So this test is based on the concepts like if fetal skin containing phospholipid is present in the amniotic fluid, then the fetal lungs which contains the same phospholipid are said to be mature. Okay. So here we will be taking the amniotic fluid and we will be adding Nile blue sulfate. Suppose more than 50% of cells become orange in color, then lung maturity is obtained. Another test is shake test, where we will be taking the amniotic fluid and doing a shaking. If bubbles obtained, then lung maturity would have been completed. If no bubbles, then lung maturity is not attained. Okay, this test is a outdated test. We are not doing this anymore. Coming to the gastrointestinal system. Most of the content of the bowel is meconium. Meconium consists of protein, fat, cells, etc. Meconium is green in color due to biliverdin that is present. Meconium is expelled out in case of hypoxia or stress, and that can be aspirated by the fetus, which can lead to chemical pneumonitis. Few points on fetal endocrinology. Anterior pituitary hormones like growth hormone, ACTH, prolactin, thyroid stimulating hormone, and gonadotropins are secreted from 8 weeks of gestational age. Posterior pituitary hormones like oxytocin and vasopressin are secreted from 12 weeks of gestational age. Thyroid hormones produced by 12 weeks of gestational age. This is important for the growth of the fetus as well as brain development. Pancreatic hormones like insulin is secreted from week 12 and glucagon seem to be secreted from 8 week onwards. I hope you would have understood the fetal development and the important system development also. Until we meet in the next video, take care and bye bye.